3 minutes after the earthquake. We issued our initial bulletin 4 minutes after the earthquake, and our first formal message 9 minutes. Hawaii was put into a watch 10 minutes after the earthquake. The first wave reached Nauili 7 hours after the earthquake. And then we saw what the tsunami was doing all around the islands. And at 11 hours and 45 minutes, so that was 11 hours after the earthquake, we downgraded the warning to an advisory. Now, the warning means you have to evacuate. An advisory means you can re-enter the areas that you evacuated, but stay away from the ocean. And then 15 hours later, so this was 11:30 local time, we canceled the advisory. And maybe we were a little hasty in doing that, because some people had been, the tsunami arrived at 3 in the morning, and so people had lost a lot of sleep, those who evacuated, and they'd been sort of pent up in their evacuation places, and then finally we cancelled the advisory, and everyone goes to the beach. But there were still currents and still pretty sort of strong waves. So it was a little scary, but fortunately no one was injured. The tsunami, of course, kept on going, went all across the Pacific. It didn't reach Chile, the other side of the Pacific, until almost a day after the earthquake. And in fact, it wasn't until 25 hours after the earthquake that we finally canceled the warning for the entire Pacific. This is what happened. This is the tide gauge in Kahului. And these are 4-hour increments across the bottom. So you're looking at 2 days of data here. And here's the tsunami coming in. The maximum height in Kahului was, these are meters, 1-2 meters. So this was 1.5 meters. No, it was 2 meters high when it first hit in Kahului. It actually hit the peg on the tide gauge and maxed out. And then the water just oscillated and oscillated and oscillated and oscillated. One wave every 20 minutes for a full day afterwards. So you can see what our difficulty is in cancelling the advisory. We have to decide when this oscillation has got small and is going to remain small. Okay, the evacuation maps. This is downtown Honolulu. These are the new maps. Our maps are very good, probably the best in the world. We have a lot of data from previous tsunamis, how much flooding they caused, and from what we know about earthquakes, we have gone all around. This is actually the work done by Kwok Fai Chung at the University of Hawaii. Put big earthquakes all around the Pacific and seen what the tsunami is going to be like from the worst case earthquake, and then draw an envelope around that, and then that's the basis for the evacuation maps. And then that information is turned over to the city and county, and they draw the line along some road or near some geographic feature, so the police, when they set up roadblocks, they know where to put it. So this is downtown Honolulu, Honolulu Harbor. I show this because this is one area that is very different. The old maps did not have evacuation of downtown Honolulu. Now we do. The reason for that is we know that a tsunami can come into Honolulu Harbor and actually set it rocking so that it will overflow back here at U.S.A. If we have an earthquake within the Hawaiian Islands, almost certainly the big earthquake, it's going to be somewhere near the Big Island. The worst case for us would be the Kona coast, because if the earthquake is on the southeast side, where most of our big earthquakes are, if it's on the southeast side, we don't really have to worry. It's not going to hit us in Honolulu. But if there's an earthquake on the Kona coast, then the first wave of the tsunami is going to arrive in Honolulu after about half an hour. It's not going to be very large. Fortunately, it dies out with distance quite rapidly, but the shoreline is dangerous. So if anyone's on the beach, we want them to get off. Now, it's only half an hour. So what we've done to handle this situation is we've peppered the islands with seismometers so that if there is an earthquake, we'll know about it fast, and we will get a warning out within 3 minutes of the shaking. So you'll have like 25 minutes at the worst. So if you feel shaking and the sirens go off, just move inland. Don't have to move very far. The evacuation zones as they exist in the maps are fine. They're in fact very conservative for a local event. Okay, so these are my comments. Most important, the tsunami is more than one wave. The survivors I've talked to, all of them say, you've got to tell them a tsunami is more than one wave. So I'm telling you, tsunami is more than one wave. Very often the first wave is small, you think it's over, you go back to the beach, and then 10 minutes later another wave comes in and gets you. After the warning is lifted, please remain cautious. Okay, in 2010 we had 15 hours, this year we had 7 hours. Imagine if you only have a few hours. I say here 3 hours, that's the worst case. In fact, we'll almost invariably give you more than that. A big tsunami that's going to cause a lot of damage, we'll give you 4 hours warning. If you're out of the evacuation zone, stay where you are. Don't get on the road, because there's already a bunch of crazies on the road. You know that. And finally, if there's something local, if you feel shaking, and then like a minute later, actually it'd be less than a minute, it'd be about a minute for Oahu. If you feel ground shaking and then sirens go off, move inland, and then find out what's going on. So thank you.
Thank you, Dr. Fryer. Always appreciated. My name is Hirai with the Department of Emergency Management, City and County of Honolulu. I'd like to call up Mr. Michael Cantin, who is the Warning Coordination Meteorologist for the National Weather Service Forecast Office. How about a big hand for Michael?
Well, thank you, everyone. It's always great to get applause before you start. At least you get applause once, because in the end, if it's bad, at least you clap for me once. So, I'm grateful to be here with you today, and I see it's a big crowd, and it makes me think of Billy Joel, Piano Man. It's a pretty good crowd for a Saturday, right? It's pretty good. Early morning, great that you're able to come out. So, okay, my name is Mike Cantin. I'm the Warning Coordination Meteorologist. What that means is I'm part of the management team at our office at UH Manoa. Part of what I do is coordinate with local authorities, civil defense, Department of Emergency Management, first responders, fire, police, all those folks, to be prepared for weather hazards and prepared to mitigate those hazards and to educate the public. That's kind of my main role. I work with schools, civic organizations, others doing similar talks like this and other weather safety. So if any of you are interested in that for your community organization, please feel free to talk to me afterwards and we'll get you hooked up. So today I'm talking about tropical cyclones, hurricanes, tropical storms, and we'll get rolling. And let's talk about our office, the Central Pacific Hurricane Center, and who we are and what we do. So how many of you are familiar with the National Weather Service? So we have 39 meteorologists, 39 staff members, including about 25 of those are meteorologists. We have electronic technicians, programmers. Our responsibility for tropical cyclones encompasses what we call the Central Pacific Basin, which goes from 140 west to the date line and north of the equator. I'll show you a map in just a minute to kind of give you a perspective on where that is. In addition to worrying about hurricanes and tropical systems, we do aviation forecasts, climate forecasting, marine, public, surf forecasting, fire weather, daily forecasts. We have quite an array of forecasts that we do and information. So we're involved in a lot of different types of projects. And so whatever your interests are, I'm sure we cover some of that. So here's a review of our areas of responsibility. This top left is actually our area of aviation responsibility. So any trans-Pacific flights coming from the Western Pacific and Asia, Russia, will cross through this area. What we do is we forecast for turbulence, we forecast for volcanic ash, the radiation plume from Japan, and they're having issues with the plants there. We were in charge of tracking, in part, where that radiation is going, and whether we need to highlight it for air traffic and that type of thing. So we cover a very large area. We do marine weather forecasts for wind and waves and sea state for the North and South Pacific, about 15 million square miles of the Pacific, so any boats traveling across that portion of the Pacific get their forecast information from us, and we routinely get inquiries from all over the Pacific about our forecasts. And here's the globe broken down by area of responsibility for tropical cyclones, and here's us, this little wedge here in the Pacific, and I say little, but it is very large. The National Hurricane Center in Miami, most of you are probably familiar, you've heard them as well. They cover the Atlantic, Caribbean, and then the Eastern Pacific here, and then we pick it up at after 140 West. Now we also do backup capability for the Eastern Pacific, so if they get really busy in the Atlantic or the Caribbean, we can pick up the workload and cover any systems that form in the Eastern Pacific. So we do cover mainly the Central Pacific, and most of our storms come from east to west, which we'll look at in just a sec. So what happened last year, 2010? Anybody remember? Nothing, except for what's on the screen that you're reading right now. It was a very quiet tropical weather season for the Central Pacific, which is very good. We like those seasons. We had one storm, Omeka, that formed on the 16th of December. It actually formed west of the date line. The Japanese Meteorological Agency covered it there, and then it moved east of the date line, and we picked it up. It impacted the northwest Hawaiian island chain, peak winds about 50 knots, which is about 56, 57 miles an hour. So overall, it didn't impact us very much as far as the main portion of the state. Here's a plot of where it was. So the date line is right here. This light line followed the wiggly red dot. And so that's where it started. It kind of curled down to the south and then recurved to the north. It was a well-organized system, but didn't last too long. All right, so what do we normally get? So that's what we saw last year. It's pretty quiet. We know that we do get tropical cyclones in the Central Pacific. What do we typically get? We typically get about 4 to 5 tropical cyclones that form or pass through the Central Pacific. Okay, a lot of them form in the Eastern Pacific and then track their way to the west and then cross through. But in general, it's about 4 to 5. About 1/3 of those end up as hurricanes, the other third as tropical storms, and the other final third there are tropical depressions. And we'll go through, real quickly, the definitions of what those different terms mean. It's really just all about wind speed. As you go up from depression to hurricane, the wind speed gets stronger. That's pretty much how it works there. We have had 3 direct hits to the state in the last 50 years. The Dot was the earliest one, 1959, Eva in 82, and Iniki in 1992. Most of you probably remember Iniki. Some of you probably remember Eva, and then a few of you may remember Dot. Anybody out there willing to admit it? Okay, excellent. It's good. There's no shame in that. Okay. So you remember Iniki well, and especially the folks who live on Kauai remember it very well, and they're getting very well prepared for another. This graphic down here, which will be kind of hard for you to see, it looks like a bunch of squiggly lines, like a plate of spaghetti that was dumped on top of the state of Hawaii, right? Okay. Each of those lines represents a path of a hurricane between 1949 and 1998. Okay? So here's the state right here. And you can see most of them track from east to west and head south of the state. Okay? A couple of them have recurved and impacted Kauai. Those are the 3 that we're talking about, the direct impacts. Some have approached from the east and then petered out and moved to the north, or just dissipated, like Flossie and some others over the last couple of years that approached. We started to get pretty excited about it. It's heading straight for the Big Island, right? And then it dissipated, which is a good thing. So this time of year, we get some pretty decent weather, don't we? And we get winds that come from the east-northeast. We call those trade winds, right? And they blow pretty much consistently, say, from March all the way through October. And it's pretty consistent. Sometimes they're stronger, sometimes they're weaker, but they're pretty much there every single day. The reason for that is because we tend to get high pressure that forms north and northeast of the state, kind of up in this ballpark if you think of the Pacific. The winds rotate clockwise, in a clockwise direction, we call it, around that high pressure. So they'll funnel in from the northeast. Okay? Tropical cyclones are an area of low pressure. So when it sees or feels the influence of high pressure to the northeast, it says, whoa, I don't like pressure. I'm going to move away from that big blue H that you'll see on the weather screen. Okay? So the storms will approach it and then go, whoa, and then hook around it. Okay? So because we consistently have high pressure to the north and the east of the state, tropical cyclones tend to come along, feel the high pressure, and then curve down to our south. So it's not the Big Island, protecting us because of the volcanoes. Sometimes people talk about the volcanoes are so big that they change the weather patterns so we can't possibly get by a hurricane. That's not the truth. The key is that ridge of high pressure, okay, and the water temperatures, which are usually warmer down in the south and the southwest. So as long as that ridge is there, we're fairly well protected. Okay? It's the times when the ridge weakens or the storm forms down to our south and can already scoot around the ridge that impacts the western portion of the state. Okay, does that make sense? Okay, so if you're seeing the big blue H and trade winds, we're pretty much in good shape. Like if a storm formed right now, I think we're pretty darn good shape. It would pass directly to the south. We got to worry about when that ridge weakens and backs off to the north, which happens, and then the storms can scoot their way towards us. Okay, let's talk about some more graphs. So this is the tropical cyclones between 1970 and 2010 by month, all right? You can see by far our peak season is between July, right now, through October, with a peak in between July and September. In that 40-year span, we've had 68 tropical cyclones in the Central Pacific in the month of August alone. Okay, that's more than one per year, okay, approaching 2 per year. And another thing to point out is that every month in the last 4 years, except for February and May, has recorded a tropical cyclone in the Central Pacific. So our official season is June 1st and November 30th, but they could happen anytime. All right, so just kind of keep that in mind. But we are heading into the active season. It's been very quiet so far. And now we're starting to see over the last week or so, things are starting to pick up a little bit out there. Okay, so we'll keep an eye on that. We are heading into our peak, so now's the time to really be thinking about what you need to do. Now let's break down those 40 years by year and talk about a couple of different things. So what you'll see is, look at these graphs. There are some peaks and valleys in there, but in general you see a trend for 2, 3, 4. Remember our average is 4 to 5, kind of below average. In the 70s, you get into the 80s to early 90s, we're at 6, 10, 8, 7, 11s, 5s, a little bit above average for that time frame, and then over the last 10 years, we're actually been below average. So we're kind of at a point where over the last 10 to 12 years, we've seen below average amounts of storms in the Central Pacific, but we're at the point where that's going to change potentially, and we'll get back into the cycle of more active periods. But the real point to take away is that no matter how active the season is, all it takes is one storm. Okay? So this year we're predicting about a 70% chance of below normal season. We're saying 2 to 4 storms is what we expect in the basin through the year. But if one of those storms happens to be the one that strikes the state, we're going to get the impacts that we worry about, okay? This graph shows you our forecasts since 1984 to the current time, and the average error. The average error as you go up the scale means it's worse. Down towards here, it gets better. And the trend is that our forecasts have been getting better over time. Now, we're reaching a point where we've kind of plateaued over the last several years, and the state of the science and tracking the location and movement of a hurricane has kind of gotten to a point where we're kind of stuck. So we're looking for ways to improve that. But just to prove a point is that right now, our average error, 12 hours out from where the storm is, we just talked about that, is about 50 miles. So when we say the storm is say, southeast of Oahu by 150 miles, right? And then we say in 12 hours it's going to be just south of Honolulu. There's a chance that it could be 50 miles off just about in any direction from there. Okay, so keep that in mind. So our forecasts are fraught with error. We all know that all weather forecasts are right all the time. Yeah, right? Okay, so we translate the errors that we have on a daily basis into a hurricane forecast. Just remember that there's potential issues with that. Real quick, tropical cyclones. This is just a generic term talking about tropical storms, depressions, and hurricanes. The difference between a tropical cyclone and an area of low pressure is that a tropical cyclone has a warm center. I won't go too crazy into why that is and what's the difference, but that's kind of the main difference there. Depressions have winds up to 38 miles an hour. Tropical storms have winds of 39 to 73, and when it gets to that point, we'll assign it a name. And then hurricanes have winds of 74 miles an hour or higher, and there's 5 categories, and category 5 is 155 miles per hour, sustained winds or higher. Okay? We have watches and warnings. The basic idea is when we do a watch or warning, we are trying to tell you the time when tropical storm force winds will arrive at your location. So even if it's a hurricane warning or a watch, we're not saying when the hurricane winds are going to arrive, we're saying when the tropical storm winds arrive. And the reason why is when winds get to 39 miles an hour or higher, those people who are in charge of helping you in your life safety, when you call 911 to come get you, well, their main mission is protecting lives, right? So they're not going to send out and dispatch people to go rescue you when the winds are greater than 39 miles an hour because of the safety of the individuals in that ambulance or fire truck going out. So when the winds get to 39 miles an hour, between then and when they drop off, you're on your own. Okay? People will not come to get you. And most likely by that point, we won't have phone, we won't have power anyways. You know how the wind blows. On this side, I live out here, March 4th, the wind blew for 50 miles an hour for about a minute, knocked out power for about 16,000 people, right? That's when the strike occurred and all that. So that's one wind gust of 50 miles an hour. A hurricane will bring winds of 74 miles an hour that'll last for 4, 5, 6 hours straight. Okay, so you can pretty much guarantee you won't have power or much of that infrastructure as well. Last thing we'll talk about impacts. I always feel like a doomsday. Okay, hopefully you can smile after today because you're getting a lot of, tsunamis, death and destruction, hurricanes, death and destruction, and preparedness. But think positive. We can be prepared and make good choices and we'll be safer. So what are the impacts? Well, we get extreme winds. Iniki had wind gusts that were higher than 150 miles an hour. Eva, they were over 120 miles an hour. So I just mentioned the March 4th. All the infrastructure damage, the power lines, the trees that went down, for one gust that lasted less than a minute of 50 miles an hour, and then some wind gusts for maybe up to an hour, about 30, 35 miles an hour. Can you imagine 120, 140 mile per hour winds on the island of Oahu? I don't think we can conceptualize the potential damage, wind damage, that could happen to this island or anywhere in the state. But because of the infrastructure and the amount of people that we have here, the potential is extreme. We really need to be vigilant and understand that the impacts that happened in Kauai, they were isolated for several weeks, but the airport and other transportation here in Oahu, well, we were able to get to them. Our infrastructure wasn't damaged. On the west side there was some, but the main infrastructure of airports and that type of thing, we were able to get to them. But if it's us that gets hit, who's going to come to us, right? Most likely it'll come from the mainland, and that's days away, depending on how much damage there is to the airport. So we need to be prepared for an extended time, 10 days to 2 weeks to be prepared. There'll be more preparedness later on. Flash flooding, we get some heavy rain. We deal with that all the time here in Hawaii. 14 inches of rain for a tropical depression, 8 to 10 inches for Iniki, and I know, less than a minute. He's being kind because he's giving me more time, I can tell. So one thing real quick about tropical depressions and hurricanes. Hurricanes are a real big wind threat. I think of like a buzzsaw or a chop saw, when you're cutting a 2x4 and you go and cut it, right? Okay, hurricanes like that, spinning really fast, really strong winds, but they tend to move pretty quickly. They're in and out, okay? Tropical depression is spinning a little bit slower, winds are a little bit lighter, and they tend to move slower. So when they're producing heavy rain, they'll just slowly creep across where you are and just inundate you with flooding rain. So we tend to get more rain with depressions and storms versus the wind threat with a hurricane. Okay, some of the different impacts that you might see. Storm surge, so Iniki pushed the ocean up about 3 to 4 feet and had 30 to 35 foot waves. So you can imagine a storm approaching South Oahu, Hamala Bay, and working its way in. And the surfers like it. They get out there, they get, head high, double head high waves like over the last couple of days and a couple of weeks ago, and they think it's awesome. It's breaking right by the harbors. It's no big deal. Can you imagine 30 to 35, 40-foot waves coming into to Waikiki in those areas? A major impact from that. We don't see that. We see it on the North Shore, but the reef is different. The symmetry, the way the ocean is shaped, everything kind of protects a lot of areas. They can get 40, 50-foot waves offshore. Not too big of a deal. If we get that in the South Shore of Oahu or other places, that's a really big deal. Okay, we got to worry about that. And just real quickly to reference, we just heard about tsunamis from Gerard, and the difference between a tsunami and a storm surge. Storm surge is created by this hurricane or tropical system moving along, and the winds are blowing in the same direction for a long, long time. And the winds push the top of the water along, okay? They just push it. And then the water eventually piles up. And when it gets close to the shoreline, that pile of water moves in as the wind pushes it in, okay? When the winds back off, the water will recede. It may be on shore for hours, as long as those winds are blowing. So while a tsunami comes in and out, storm surge will come in and stay there, and then the winds will be whipping all the water around, and then it'll move back, okay? And so that's just the main difference between the two. Thank you.
Again, on behalf of the mayor and on behalf of my boss, Director Mel Kaku, thank you for coming. So this talks to the cycle of disasters. In essence, what happens is a disaster occurs and we go into response mode. And when I say we, I don't mean just the Department of Emergency Management. I mean the whole city and county, our state partners, our federal partners, our private partners with the Red Cross and everyone else. We go into response mode to try to minimize the loss of life and minimize the loss of property. We then go into recovery, where we try to get back to normal again, provide you essential services again, like police, fire, sewer, water, trash, pickup. And then we go into prevention mode. And prevention and awareness are those things we're doing right now when there's no disaster. People often ask me, what do you do when there's no disasters? You just sit around. No, we don't just sit around. We do things like this, where we come out to the public and we try to educate the public on disasters. People like Simpson Strong Ties that you see back there, they're part of our prevention mantra, providing for protection for homeowners. And then we go right back into preparedness and the next disaster comes by. And as you already heard from our previous two speakers, hurricanes, tsunamis are constant dangers or constant hazards here in Hawaii. I'm going to talk about preparedness, and I'm not just going to talk about preparedness from DEM city government standpoint. I'm going to talk about overall preparedness, actions you can take to be better prepared for the next disaster. And it's very simple. You make a plan, you get a kit, and you be informed. Okay, that's it. Make a plan, get a kit, be informed. Okay, make a plan. These are some of the basic things you can do to make your own family or individual disaster plan. Identify who you want as an out-of-state contact or out-of-town contact. Why an out-of-town contact? Because sometimes local phone service is down, but interestingly enough, you can get long-distance service. So have an auntie and uncle or a relative outside of town that you all can contact, and then when you call back, they'll say, everybody contacted me, everyone's safe from your family, your daughter is at this and this location, your parents are here and here. So everyone can check in with that out-of-state contact, and you can find out if everyone's safe. Share each other's numbers. Obviously, you should all have each other's numbers on speed dial or some kind of method that you save it on your telephone so you can quickly get in touch with your family, quickly get in touch with 911 or other services. Poison Control Center is another good number to have on your phone, especially if you have little kids. Have it on speed dial so that you know you can call the Poison Control Center right away. If you can't get through with your telephone, try texting. Sometimes text services will work even if local phone service isn't working. So if your phone doesn't work, try texting your kids, try texting your parents or whoever it is that your loved ones. Surprisingly enough, it does get through a lot of times when the phone is not going through. You can subscribe to alert services. There's a bunch of services out there. National Weather Service has a feed for hurricanes that you can sign up for. It's RSS, right? RSS feed. Tsunami Warning Center, I think, has a feed that you can sign up for. But the city and county has a service now that we use. It's called Nixle. If you can't read that, up there it says www.nixle.com, Nixle. You can sign up free of charge, and you can sign up for an email service and or a text messaging service. It'll give you alerts, it'll give you warnings, it'll give you just advisories. Like for instance, for this meeting, we reminded people that this meeting was occurring today. Twice, we shot something out on Thursday and we shot something out yesterday saying final reminder. Part of your plan needs to tell you if you need to stay or go. Okay, stay or go. Do you stay in your house during that disaster? Is your house safe? Are you outside the tsunami evacuation zone? Or do you need to evacuate to a public refuge area or a public shelter? Okay, those are the questions you need to ask for every kind of disaster that could affect you. Okay? Whether it's a flooding is very, very possible anywhere on this island. As the National Flood Insurance Program will tell you, floods are always a possibility no matter where you live. And rehearse your plan. Okay, if nothing else, rehearse your fire evacuation plan. Make it a fun activity for the kids. I mean, stress how serious it is, but make it a fun activity where everybody's crawling outside the house safely and everybody's meeting outside the house. You can practice ducking under the tables for earthquakes. Practice walking over to your closest community shelter. Okay, we have a list of hurricane shelters on websites, multiple websites, ours, as well as state civil defense. Okay, next thing is to get a kit. You can make a kit, you can buy a kit. American Red Cross sells excellent kits. A bunch of other folks sell disaster preparedness kits online. You can make one for yourself. Use a rolling bag, a rolling cooler. Rolling cooler is my personal favorite. You know those big coolers with the wheels? You can put all kinds of stuff in there and you can have it ready to go. Just pick it up and go when a disaster happens. You can have a backpack if it's your personal disaster kit that you want to keep mobile, you want to stay mobile. Have one for your car, your home, or your work. Consider how you're going to stock water. Water is sometimes can be the most challenging thing about a disaster supplies kit. Okay, how are you going to keep water in there? They have something called a water bob. The water bob is a huge plastic bag, is what it is, a thick, puncture-proof plastic bag. And amazingly enough, it's in the exact same shape as your bathtub. Okay, so what you do is you unfold this bag, you take it out of the box, you throw it in your bathtub, and you fill it up with water. And you then have clean drinking water, clean cooking water, and clean hygiene water to use during a disaster.
Water fresh for a month.
It keeps water fresh for 1 month. I didn't know that. That's great to know. Okay. Empty containers if you want to keep to fill up during a disaster, or you can do bottled water. If you buy bottled water, make sure you check the expiration date and rotate it out. And you can also have homemade bottled water. That's what we used to do at the Red Cross when I worked there like 20 years ago. We would make big 5-gallon cans of water and we would put a couple of drops of Clorox inside, and you know, it tastes kind of like mainland drinking water, a little chlorine-y tasting, but other than that, it's drinkable. Also consider special needs when you make a kit. Okay, if you have elderly, infants, pets, any kind of special diets or medications. Some of the things you need in your kit. And if you can't read that from the back, we've got food, we've got water. Minimum requirement for water is 1 gallon per person per day, and that's for both drinking and for hygiene. Small portable radio, flashlights. One tip I like to tell people is if you buy a radio and a small radio now, not a boombox, okay? If you have a boombox, it's going to suck up D batteries like you won't believe, and you're going to have to keep buying batteries. A small portable radio and a flashlight. If you buy both, see if you can buy them where the batteries match. So I always have a ton of AA batteries, so make sure they match so that you can buy extra batteries for both. First aid kit, just a small, cheap first aid kit. What's the minimum thing you should have in a first aid kit? 2 things, one to clean and one to cover. Okay, one to clean and one to cover. So something to clean wounds out and something to cover wounds, okay? Because after a disaster, biggest thing that you need to worry about is infections, especially from funky water and funky stuff and funky debris. A whistle, dust mask in case you got a lot of debris and dust. Towelettes, garbage bags, and ties. What is the towelettes, garbage bags, and ties for? That's in case the toilet's not working. Okay, you can make your own toilet. Okay, all you need is some wet wipes, some garbage bags, and some ties to tie it up afterward. All right, make your own little make your own little portable toilet. You can use a 5-gallon bucket. You can use whatever you think you have. In an emergency, again, when the sewer's backed up, when everything's down, that's what you need in a pinch. Non-electric can opener. Non-electric. Okay, it's really gonna suck if all you can eat is Spam and corned beef, because that's all you can pull the tabs off of. All right, so make sure you got a non-electric can opener and a cell phone with a charger. Good idea to do is, even if you don't regularly do this, is to buy a car recharger for your cell phone if you don't already have one. You might have the regular wall plug one, but buy one of those plugs for your car, because when the power goes out, you can still recharge your cell phone in the car. Other items, and these are just recommendations. The other stuff was requirements. These are recommendations. And as Michael said, make sure you have 5 to 7 days of supplies at a minimum. 5 to 7 days. Okay, that's how long you're probably going to have to be self-sufficient. Okay, be informed. Be informed is the last thing I wanted to tell you about. Know how much time you have to react, how much time you have to prepare. Okay, Michael Cantin told us that they're going to issue a watch. When they issue a watch, that's when you should be preparing. The only other thing I wanted to mention was our CERT program. The city and county sponsors a Community Emergency Response Team program, CERT. If you want to take the course, it's 20 hours long. We break it up into 3 different days, so you're not going to spend 20 hours in class straight. And what you qualify for is you get a free kit that comes with the program if you're certified. Okay? And you can become a community responder. And what it's designed to do is if we have a huge disaster where police, fire, emergency medical services may not be able to reach you afterward because roads are blocked, then you will self-activate and you will help your neighbors, your friends, your family to recover from that disaster and provide for emergency needs.